Jai Hind, I am Madhup Agrawal from Akgec IT department. Today's our discussion topic is 3D array. Previously we have already discussed 1D array address calculation and 2D array address calculation. Now we will discuss 3D array address calculation. So first we see what is 3D array. A 3D array is a collection of two-dimension array. This is a collection of two-dimension array and it is specified by using three script or indexes. First is page script. This is also known as block script or frame script. This is first script, and second script is the row size, and third one is number of column. As we know, in the 2D array there are only two script. First is row, first is this row and second is column, but here we have one more script, that is number of pages. We say it. There are three scripts in the 3D array. So first we understand deeply what is 3D array. So as we have mentioned here, this is a collection of 2D array. So we can also see this as in this form. Just guess, this is a 2D array, this is another 2D array of the same size, this is another 2D array of the same size. Okay. So this is a collection of two-dimension array, means this is a collection of two-dimension array. So this is a 3D array. Now we see that there are many 2D array in the 3D array. So we call it first 2D array as page number 1 or page number 2. If we start the script from 0, then we say that this is a page number 0, this is page number 1 and this is page number 2, or frame number 1 means frame number 0, 0 script, frame number 1, frame number 2, we can also say. So how to calculate the address in this situation? So we can represent these collection of 2D array in this form, in this block form. This is block form. This is the first page, on back side second page, on the back side third page, fourth page and so on. So this is just like a 3-dimension figure, so we call it as a 3D array. First index, this is first index, means number of pages, this is second index, means number of rows, and this is third index, indicate means number of columns. Now how to find the address? To find the address of any element in the 3D array, there are following two ways. In the two ways, as in the 2D array, means row measure and column measure, as in 2D array, we can also find the address in the 3D array in two manners. One is row measure, another is column measure. So how to calculate in row measure and how to calculate in column measure? First we see what happens in row measure. In the row measure, all the rows, all the element stored row wise means all the elements of the page number first, means page number, this script is 0. So page number 0, all the rows stored, means this element are stored first, and then the second row of this particular page is stored here. Now the third one is stored here. So all the elements row wise is stored for the first page, and then the second page element are stored row wise. Second page element are stored row wise, means this element are stored here. In continuation, we also know that this is continuation allocation of memory, as we are using array. Now element this is stored in this sequence, and then this one further. Okay. So in this manner we store the elements in row measure method. And in the column measure method, how to allocate? In the column manner per page. So, element this, and this in the column measure, this is row measure, and in the column measure this means all the elements of the first column is stored first, means here, then elements this and this are stored here in continuation, element of this and this are stored here, and then the third column elements are stored here in continuation, just like this one here. Then the turn come for the next page, and next page element are also stored in the column measure, first, second and third column, and so on. In this case, first, second and third. So, in this scenario, we are going to calculate the address of 3D array in the row measure and column measure. So, first, how to calculate in row measure system? The address of the location in row measure system is calculated using the formula. This is a formula, address of A, P, I, J. P is the desired page, I is the desired row, and J is the desired column index. The formula is this one. What is B? Here we already know B is the base address of the array. What is W? W is the word size, or we can say the how much bytes a particular element of the array occupies. And now, so this is same as 2D, and this is multiplied by number of element before the desired element. We are calculating number of element before the desired element. Number of element before the desired element. So, we are calculating here. How to calculate? We are calculating it into the three parts. Just see here, first part is here, second part is this one, and third part is this one. So, here, because this is a 3D array, so we are calculating in three parts. In the 2D array, we have calculated in two parts. So, what is m into n? Now, m into n. First, we see what is m, what is n, what is LP, what is n, what is, and so on. What is LR, what is LC? First, we see here. First, we see here. B is the base address, and P is the page script of the element whose address to be found, as we have seen, and I is the row subscript element whose address is to be found, and J is the column subscript of the element. This is for column, this is for row, and this is for P is for page, desired page, and W is the storage size of one element, and LP is the lower limit. This is L for lower, P for page, lower limit of the page or start page index of the matrix. If not given, assume 0. LR, lower limit of row, as in the case of 2D array also same. If not given, then assume 0. What is LC? LC is the lower limit of column or start column index of the matrix. If not given, then by default is 0. And what is M? M is the number of element in the column. M is the number of element in column, and N is the number of element in row. How much element in row is represented by N, and how much element in particular column is represented by M. So, how much element in a particular column? Just see here, if our, so how much elements in a column? How much elements in a column? Here 3, because there are 3 rows. So, how much element in particular column? That is number of rows. And how much element in particular row? how much element in particular row? In a particular row, how much elements are here? 1, 2, 3, 4, 5. This is number of columns. Number of columns of 5 means each row occupies 5, contain 5 elements. Okay. And we will see further. So, we are currently here. So, m n to n, we are calculating m into n, number of row, number of element per row, number of element per column. So, we are calculating here number of elements per page, number of elements per page, we are calculating number of element per page, and then this is now P LP, lower limit of page, P sorry, one part is here, this is from this one to this one, first part, not this one, first part is here, second part is this one, and third part is this one. This is for page, number of element calculated for elements before the pages, and this is for number of element before the row, and this is column. So, P minus LP, P desired calculation for page and LP is the lower limit. If not given, then this is 0. Now, this is n, number of element per row, into I minus LR. I is the desired index which we want to calculate, and LR lower limit. So, number of element in the row, and in that particular column, where the element is present, we are calculating element before that in the column, that is J minus LC. Okay, this is the formula generally here. In the column measure, we can see in the column measure the address of the location column measure system is calculated using the formula this one. Same here, B plus W into number of element before that particular element, we are calculating here this one number of pages element, second one number of element before that particular element row wise, and number of element in that particular column. Okay. So, just see here, we are calculating number of element per row, here we are calculating number of element per column, and this is J minus LC comes here and I minus LR comes here. So, by using examples we can see, we can understand these concept. So, comes into the example, just here given an array ARR having the index this one, this is for page, this is for row, this is for column. So, page index start from 1 and up to 9, and row start from -4 and comes up to 1, and this is for column, start index is 5 and ending index is 10, and with the base value is 400, base address is given 400, and size of each element is 2 byte, this is W, this is W in memory to find the address of element ARR 5. Desired page is having index 5, and this is -1. Desired column, desired row is -1, and this is 8. Desired column is script have 8 index. Now, with the help of which one? With the help of row measure and column measure both. So, first we will see row measure. Now, see here, page subset of the element whose address is to be found, this is 5, and row subset of element whose address to be found, this is -1, and column that is 8 whose subscript is found, address to be found, and base address, first we note all the data given, base address B is 400, okay, and storage size W is given 2 bytes, we have note down here, and lower limit of page, the LP, lower limit of page is this one, LP, and lower limit of row is given, this is -4, that is LR, and the lower limit of column, this is given as 5, that is LC, okay. It is given, if not given then we can assume it 0, but here this is given, so this is written. Now number of rows means number of element in a column, that is M. So see here, number of element per row, here we are calculating, this is number of rows, starting index is -4, just see here, then -3, then -2, -1 and 0 and then 1. These are the indexes of row. So how many rows? Here? 1, 2, 3, 4, 5, 6. Okay, this is 6 rows here. So number of rows means number of element in a column. We can calculate by upper limit of row minus lower limit of row plus 1, just. So upper limit of row, that is 1, the lower limit of row, that is -4. So -4 and plus 1, we get the answer is 6. We have already seen here in this form 1, 2, 3, 4, 5 and 6, and by using formula we can easily calculate number of rows, that are 6, and number of columns is upper limit of column minus lower limit of column plus 1, upper limit is 10, lower limit is 5, then plus 1, 5 plus 1, that is 6. We have calculated this. Now put all the values in the formula given. This is the formula, put all the values. Base address 400, W size 2 into M is 6, N is 6, desired page 5, LP is 1 and number of N is 6 into I and J 8, LC 5. We have put all the values here and calculate the address. We have calculated, this is 36, this is 4 plus this is 6 into this is -1, this is plus 4, that is 3, this is 3 and 8 minus 5, that is 3, and again calculate the address and the final answer is 730. The address of this particular 5 minus 1 and 8 script, having the script this is 730. Now in the column measure, also calculate by using the formula, that is B plus W into this M into N into P minus LP plus M into J minus, now J comes here, row side, column side comes before, then I plus I minus LR. Now put the values for this particular subscript 5 minus 1 and 8, we have put all the values here and calculated answer. Okay, now the same answer, just like the row measure, no problem, we can get the same answer, but for the different values here. So LP is this one, now J is this one, LR is this one, I is -1, we have put different values according to formula and get same answer, no problem. Okay, so till now, to understand better we can consider another example also. So just see here another example. Now the given array is ARR 10, 5 and 8. This is ARR 10, 5 and 8. Okay. So here no starting script, here only the size, number of pages is 10, here number of rows are 5, number of column is 8. So starting index for page is from 0 to 9 by default, from 0 to 9, because starting is not given, this is size is given here now in this case, and for this the 0 to 4 and for this 0 to 7 because starting. So here LP is 0, LR is 0, LC is 0, okay, and upper limit is 9, 4 and 7 respectively, okay. So and the given value is, base value is 1000 and the size of that is W is 4 byte, no problem in memory. Now find the address of 6, 3 and 5 index element with the help of row measure and column measure. So we will see data is collected from the given question. Now LP, LR, LC all are zeros, W is 4, base address 1000 and PIJ is given here 6, 3 and 5, and number of rows here directly given here, number of rows that is 5, directly given here, number of column that is 8. We also calculate by using the upper and lower limit, but here directly given, so no need to calculate by formula. Now row measure calculation, simply by the formula, put all the values in the formula. Here base address 1000, W is 4, M is 5, N is 8 and P is 6, LP. Now LP is 0, no problem, N is 8, I is 3, LR 0, J is 5 and LC is 0. So calculate by using the formula, that is 2076. Now get the answer very easily by using the formula. We have studied the concepts, and in the next by using column measure wise calculation. In the column measure the formula is now have changed. Now column part comes before here and number of element per column, that is M and that is I minus LR. Now put the values here, 1000 plus 4 into 5 into 8 into 6 minus, this is number of element present in the page before the element on which it is present, and number of column element, because this is storage is column measure, and number of element before that particular element, that is 4. Just put the formula, leave it. So we have found 2072 address of this particular element. This element having the index 5, -1 and 8 is present on this particular address in memory. Okay, I think we have studied enough and need the more practice, but we can attempt personally how to calculate the address. Just do 1 or 2 examples by yourself. Okay, thank you.